Hello and welcome to Organic Chemistry, Chem 241. First, a quick introduction. My name is Instructor Miller. You'll be able to see my head talking on a lot of the videos that you watch throughout this virtual online lab this summer. You might actually see, if you come to my office hours, Madeline or Juliet running into the room as we're talking. My wife, Lorian, will also be staying home this summer, and hopefully she'll be able to entertain my daughters, especially during times like office hours. Just a quick overview of some of my research experience. I did undergraduate work at Ball State, so I graduated from Ball State in 2008. I did work with our current department chair, Dr. Robert Samuelson. In graduate school, I worked under the late Dr. Ed Vides. Overall, the project was trying to synthesize diazonamide A. I was focused on a certain portion of that and have that publication. If you're interested in looking at that, let me know and I can share that with you. And I've recently been doing research with Dr. Emil, biochemistry related nanoparticle synthesis, and currently I'm working with Dr. Sergey Rosoha. For the lab, we're going to look at a Canvas course here very soon, but just a quick to-do list. The first is to navigate the Canvas site. So we're going to look at that together in just a second, but that's the first thing you need to get comfortable with starting out the course. The next is to review the syllabus. We'll also look over the syllabus in this video. And then after you watch this video and do both of those two first items, you should take the syllabus learning objectives quiz. We'll look at that on the Canvas site, but you'll have to take that independently. And then the next would be obtain the necessary materials for lab. So that specifically consists of the Chem 241 EWorkbook, as well as a potential YouTube subscription so you can watch my videos and other videos ad-free during this summer semester. After that, you want to start the stoichiometry review assignments and then prepare your carbonless copy notebook or a regular composition notebook for experiment 1. In this case, it doesn't really matter because you're just going to be scanning the pages anyway. I still think it'd probably be slightly easier to scan with a carbonless copy notebook, but it's totally up to you for what notebook format you want to use. Just be aware that you'll have to scan your notebook pages and upload them with your experiments. And then after that, the next step for you to do is to take the experiment 1 Prelab Quiz. So let's jump over to the Canvas site. Your view is going to be slightly different, so let me just jump over to student view here. So this is pretty much what your course is going to look like. The introduction video is what I'm recording now, and I'll copy the link to that once I upload it on YouTube, paste it here so you can be watching it simultaneously as you are watching this video, of course. When you click on it then, of course, you'll be seeing this video. Anyway, that's a little bit crazy, but we'll move on. So to get your eWorkbook, you need to go to this link. So you're going to go to this link, and it's going to open up this page where you are going to add the book to the cart and purchase the eWorkbook that we'll be using this summer. Once you do that, then the next link is to download the eWorkbook using the redemption code that you get once you purchase it. So that redemption code will likely be emailed to you. You can use that redemption code to then go to VitalSource, set up a username and password if you don't have one already. Once you sign in, you should be able to see the books you have access, or go ahead and enter your redemption code here so that the book will actually be on your bookshelf. And so if I go to somewhere else here, for some reason it didn't allow me to open my bookshelf because it wanted me to enter that redemption code, but once I go to the bookshelf, then I've got this book right here, and I can continue reading into it, and this contains the entire lab workbook that we'll be using this semester. So you can jump to specific experiments, or you can scroll through the whole thing. Some quick notes here. One good place to start would be to read experiment 1. And you can scroll the pages by clicking this way. So reading experiment 1 is one thing that you have to get done early this week. Experiment 2 also needs to be done this week, but experiment 2, it's a different story that we'll talk about a little bit more later. And then reading the appendix is also a really good starting point. So within the appendix, it basically walks you through a lot of the things that we're going to be doing in lab. Safety rules are something to consider because I asked some theoretical questions about that on the quiz, but that's probably the last time you'll have to think about it since we're not actually going to be physically in the lab this semester. But as you scroll through the appendix, it's got some good advice for how to write in past tense passive voice, which you'll have to do for a couple of the reports that we do later this semester, as well as specific laboratory techniques. So it basically talks you through the process of recrystallization. It gives you visuals on what recrystallization is. So if you've got an impure compound, the red stars are impurities. They represent impurities. The blue is the compound you want to isolate. This is these compounds dissolved in solution, so they're basically grayed out a little bit because you can't see them once they're dissolved in that liquid solution. And then once the crystals start to form, you can start to see the crystals at the bottom, but you can't see the impurities or the other solid that's still in solution. And then if you decant off this liquid or isolate the solid through vac filtration, then you've isolated that pure solid. It also shows you a Buchner funnel, which we often use to isolate crystals. So like I said on that previous image, it's likely that the solvent was decanted. With a Buchner funnel, you can actually isolate that solid through vac filtration. So the solid is on the filter paper up here in the Buchner funnel, and the liquid, the recrystallization solvent, is down here, which has some of your compound in it and hopefully most of the impurities in it. The rotavap is a quick discussion. I think it had an image there. The distillation setup will be very helpful for experiment 4 once we get to that point in the class. Talks about the difference between fractional distillation and simple distillation, as well as steam or vacuum distillation. The melting point assessment is as early as experiment 1, so this would be a good little segment to read for the melting point. The melting point reference table, you'll be referencing this for several experiments. This gives the dial setting for the melt temp apparatus and then what temperature that would likely jump the temperature to if you had it on that setting. Liquid-liquid extraction. So this is important because it gives you an example of a table where it shows what's happening in an extraction experiment. You'll be asked to draw this within that experiment. So experiment 3, liquid-liquid extraction, you'll be asked to draw a diagram like this. We're going to be separating caffeine and salicylic acid in that experiment. This talks about a separatory funnel, which is directly related to liquid-liquid extraction, basically what layer is what, where are the compounds, what's interacting with what. It talks about using a drying reagent. That's usually more for synthesis experiments that we'll be doing later. A quick thin layer chromatography introduction, a review on percent recovery, as well as theoretical and percent yield. So for the first few experiments, we'll be assessing the percent recovery. For the later experiments, when we're forming a product and isolating it, that relates to percent yield. All right, so going back then to this, so hopefully you can get that EWorkbook without too many problems. If you have any issues with it or anything else this semester, send me an email. I usually respond pretty quick to that, and hopefully we can get it figured out. Also, note at the bottom of this, I'll move this to something else and then block out the introduction here soon. But for the bottom of this, most of the stuff we're learning is going to be based on video. So just like this introduction video, you're going to be watching videos online to gain an understanding of the experimental procedures and the experiment of itself. Please comment on those videos. So those comments will be helpful for other students and for me to know what you're thinking, how you like the video, what's challenging about the concept, and what help that you need. It'll be more efficient for everybody if we just have those open conversations. If you're not comfortable printing those on a public forum, like on YouTube, that's fine. You can email me those questions. You can still get the extra credit. Either way, though, we definitely want to try to maintain some open communication so that way I know what the challenges you're facing are, and you can let me know how I can be of more help to you as we work through this very fast-paced summer semester together. All right, so basically you have to complete all the items in a module for the next one to open. So I think I already clicked on those links. Once you click on the introduction video, you can go back. So basically, once all the links are clicked, it opens up the next module. So now that all those links have been clicked, the next module is open. So that brings us to a good point. We're to the syllabus now. So for the syllabus, I'm not totally done editing this yet, but I think it's close enough to go ahead and share. My email address is dkmiller2@bsu.edu. You can email me through Canvas or directly through my email. I slightly prefer directly through my email better, but it doesn't really matter that much. For office hours, you saw currently have my office hours set for Wednesday and Thursday from 1:30 to 2:30. We can work out other times if that doesn't work for you. I may adjust that once we get into the semester and I see what times are more convenient for everybody. For this course, again, this is an online lab course. It's a little bit strange because in lab, the goal is for you to get hands-on experience with the chemical reactions that we're doing. But hopefully the videos walk you through it enough, and if you have any questions about anything specific in the experiment that you think would require hands-on experience to fully understand, we should definitely have a conversation about that. And we can also work on setting up meetings during the fall semester of 2021 if you feel like that additional experience would be beneficial for you. The goal is for you to increase your knowledge and have a better understanding of what those organic chemistry reactions are that you're talking about in your textbook. So it's one thing to see it on a textbook, it's the other thing to actually see those chemical manipulations happen, in this case via video. We've already gone through the 241 workbook, but this link will also take you to the redemption code site here for Van Greiner to purchase the workbook. The Ball State bookstore, I think, has something set up where you can probably find this link through that. I'm not 100% sure about that though. You also need a lab notebook, so you're going to be entering all the experiments except for experiment 2 into your lab notebook, and you can again use a carbonless copy notebook or a composition notebook. I recommend a YouTube subscription so you don't have to watch ads at the beginning of the videos. The student subscription is $6.99 a month, plus you get the first month free. So if you are going to do it and want to save a little bit of money, you could probably just get it for the first 4 weeks for free if you wanted to try it out. I think it's probably worth it to keep it throughout the summer, but that's totally up to you. Attendance is not super relevant in here. You just need to get your stuff done on time. So I've got it set up where you can just go through the modules one by one. I should have everything prepped by the first day of class. So if you really wanted to pack in a lot of stuff in 1 week and get ahead of things, you could probably get through about half the content within the first week. Now that's a lot. So this course is definitely fully loaded with a lot of tasks to do. They're all relatively quick, but it's all a lot of small individual tasks. So you definitely do not want to get behind. So if you want to jump ahead, I'm going to try to make the course available early, but sometimes the campus doesn't allow us to open it until the semester starts. All right, notebook preparation, things like that don't really matter all that much until we just jump right into the schedule. So for the schedule, I basically have the schedule laid out by week. So the first week of the summer semester is the week of 5/17, then 5/24, 5/31, 6/7, and then the last week is 6/14. There are basically going to be 2 tasks per lab day. So each lab day is a 4-hour block of time. I think that it's reasonable that you could get what I've assigned done within that 4-hour block of time, but it's going to be definitely a full 4-hour block per module, not per module, per half week. So basically it's going to be a solid 8 hours per week. So for the first week, the crucial things that you need to do are watch the video that you're watching right now, read the syllabus, and obtain the EWorkbook. And then you want to complete the Canvas Theoretical Safety and Review Quiz. So for that, basically just read the syllabus and then also read the safety notes that are at the bottom of this whole syllabus. Once you read that, you should be fully prepared to go ahead and take this syllabus, safety, and review quiz. Next is a worksheet. So there's a stoichiometry review worksheet. This is review from Gen Chem, but just to make sure we're all at about the same starting point, go ahead and complete that as soon as possible. So the stoichiometry review worksheet is also already available. And then if you want to go ahead and jump ahead of things, I'd go ahead and start also beginning your notebook entry for experiment 1. And then once you finish your notebook entry and have read experiment 1, so basically you need to read all of experiment 1, begin your notebook entry for it, then go ahead and complete the pre-lab quiz for experiment 1. For most experiments, the pre-lab quiz consists of the first 5 questions within the experiment. Experiment 1 and experiment 2 are closely related. It's essentially experiment 2 is an analysis of the product obtained for experiment 1. Reading experiment 2 ahead of time will be helpful, and all of experiment 1 and experiment 2 need to be completed basically by the end of this first week. So I would go ahead and jump into it as soon as possible. If you have any questions for me, hopefully the pre-lab quizzes and post-lab quizzes, which are only worth 5 points, will clarify some questions that you have before you jump into that worksheet, which the worksheets are really what's going to be the main determinant of your grade for the semester. The pre-lab quizzes and post-lab quizzes are going to help make sure that you've got your ideas straight and bring up maybe any questions that you have, which we can address in more detail through a discussion based on the comments, or an email to me, or setting up a time to meet during office hours or outside of office hours. All right, let's go back to the Canvas page again. So we go back here. I've got my office hours here. These may get adjusted. When you meet me for office hours, meet me through this WebEx conference link right here. So this is the link to go to meet me during office hours, or when we're taking the exam, I'm going to proctor the exam through this link. So everybody needs to be logged on to the link to as you're taking your exams. One exam where you don't have to be on there is this theoretical safety syllabus and Gen Chem review quiz. So this quiz contains safety and syllabus information, as well as a couple of general chemistry review questions for the quiz. It's worth 7 points. Once you take this, you'll be able to jump into the next module, which is the stoichiometry review assignment. So for the stoichiometry review assignment, once you open this page, these other links will become available. You just need to go through the links one at a time. You're basically going to give it your best shot on the worksheet, submit the first assignment. It doesn't matter if it goes well or not, because then you can watch the video that solves the questions that you have and then submit it for a second time, and this is what will be graded in detail. So you get 5 points for submitting the first one. This is graded in detail once you submit that, and most of the answers are given to you on this review video. So don't invest too much time in this, but if you do challenge yourself on some of those questions, do your best to answer it without looking up the answer or waiting through the review video. You're going to be better off later in the semester as it gets more challenging as time moves on. All right, that brings us to the first experiment. I'm only going to go over this and the second experiment, and then from there we're basically going to follow that pathway for the rest of the semester. So for the experiment, this first recrystallization and vac filtration experiment, all the experiments except for experiment 2 consist of 4 assignments. So for the first assignment, that is preparation of your lab notebook and watching the required technique videos to prep you for the pre-lab quiz. So the first assignment is the pre-lab quiz. You get to use your notebook on that pre-lab quiz. This is where you actually take the pre-lab quiz. So you're going to, again, watch the technique videos and prepare your lab notebook before you take the pre-lab quiz. You're going to watch the virtual experiment, and as you watch the virtual experiment, you're going to complete your notebook entry. For the notebook entry, that's going to be submitted simultaneously with your post-lab worksheet. It's going to contain answers to all your in-lab questions. Now, in some cases it says for the pre-lab quiz, if there are repeat questions on there, which most of them are, you don't have to enter it in your notebook. I recommend just entering it in your notebook. That'll be a good reference for you later in the semester, and as you are taking your exams, you can use your lab notebook as a review, as a good resource for you to answer some of those questions. So I recommend writing everything in your notebook, but the pre-lab questions aren't necessarily required. After you do the virtual experiment, you're going to take the post-lab quiz. The post-lab quiz consists of some of the later questions asked throughout the experiment, as well as some of the questions on the post-lab worksheet. So as you take this post-lab quiz, do your best, but don't stress about it too much. It's only worth 5 points. This is going to give you some good insight into how well prepared you are to do the final worksheet. If you get out of 5 out of 5 on the PostLab quiz, you're probably on the right track. Go ahead and start doing your final PostLab worksheet. If you struggle with that, definitely spend a little bit more time figuring out what the answers to those PostLab quiz questions are. Maybe ask me if we can meet for office hours for a little bit and talk about things. Maybe review some comments on the videos after a little bit more time passes to get a better hold on the content before you start that PostLab worksheet. Once you finish the PostLab worksheet, you're going to submit that PostLab worksheet plus a copy of your lab notebook entry and submit that. And again, that's what will be graded for 25 points. All right, so again, most experiments have that same outline. So I haven't detailed all of that for like the liquid-liquid extraction experiment. That's experiment 3. So there's a couple videos that you could watch to prepare you for this. Go ahead and read the actual experiment through your vital source Chem 241 EWorkbook. Take the Prelab quiz, watch the experiment, finish entering that information into your notebook, take the PostLab quiz. If you do well in the PostLab quiz, jump right into that PostLab worksheet. Experiment 2 is a little bit different because you don't have to have a notebook entry. So you want to read experiment 2 for sure. Don't worry about writing anything in your notebook. Take the Prelab quiz. Watch my presentation on experiment 2, which isn't an in-lab experiment. It just talks about some of the fundamental things that we should be aware of throughout the organic chemistry course, specifically focusing on melting point and TLC. After you watch that video, take the PostLab quiz and then answer questions 1 through 12 of the worksheet. Some of these questions directly correlate with this experiment here. Some of them are directly related to things that I talked about in this experiment. All right, that's all I have for the course introduction. That is, I think, a good starting point for you for pretty much all the content throughout the rest of the semester. Again, please email me. Let me know if you have any questions. I'm going to try to make this available as soon as possible so you can get a head start before the semester starts.